The careful operator remembers that his machine must be oiled. In most shops, this oiling is done by the maintenance department. But to take care of any slip-up, the operator should always check his machine himself to be sure that it is properly taken care of. The job problem of this operator is to machine a cast iron rectangular block to specifications. The good operator closely follows his drawing. He does not trust to memory. The drawing is the guide which must be followed throughout every operation. The drawing shows the dimensions of the finished piece. The opening between the two vice jaws must be slightly greater than the width of the piece, plus the thickness of the two brass liners. The brass liners must be free of burrs or bruises, and the vise must always be clean. The liners are used in this case to protect the vise jaws against scratches from the rough casting. Two parallels are used to bring the piece above the level of the vise and to make it solid in the vise. The piece must be clamped hard in the vise and the wrench left in a safe position. The piece is moved under the tool post for setting the length of stroke and position of ram. With the tool locked in its correct position in the holder, the operator is ready to set the ram. The ram clamp is loosened and the tool set over the work. In order to set the work properly for machining, the operator raises the table to the necessary height and clamps it in position. The piece is 8 inches long, so the length of stroke is set at 9 inches, which allows proper tool clearance at both ends of the work. On some shapers, the stroke scale is situated on the ram. The ram must be run at slow speed when setting. On the forward stroke, the cutting edge of the tool stops about 1/8 of an inch beyond the edge of the piece. On the back stroke, clearance is about 7/8 to allow time for the feed to operate before the tool strikes the work. The tool is now set to the work. Note that the heel clearance of the tool is about 6 degrees. The work is brought into alignment with the cutting tool. A machinist manual indicates the speed and feed for the rough cut. The index dial on the ram head is set at 0. This is the starting point for setting the tool to the required depth of cut, which is 250 thousandths. The tool slide is locked in place and the speed selector set at 33 strokes per minute. The term feed, as applied to the shaper, refers to the distance the work is moved to the tool or the tool moved to the work at each stroke of the ram. Vertical feed, where the table raises the work to the tool. Head feed, where the tool is fed to the work vertically. Or where the tool is fed to the work at an angle. Cross feed, where the table feeds the work horizontally, either right or left, to the tool. The operator puts on his goggles. Note the snugly rolled sleeves of his machinist coat. All good safety precautions. The piece is moved over until the tool barely clears the edge of the work. The feed control is set at 50 thousandths as shown in the manual, and the machine is started. A slow-motion study of the roughing tool in action. The careful operator always brushes the chips away from the machine. The burrs are removed so that they will not interfere when the piece is reset in the vise. The first side has been cut to finishing size. The block removed, the operator makes sure that the parallels are in place and clear of chips. The block is then reset on the parallels and the vise clamped. Since the setting of the tool has not been changed from the previous cut, it can be set down another 250 thousandths for the next cut. Notice that the operator taps the piece gently with a lead hammer to be sure it is solid on the parallels. The tight parallels prove the correct seating of the work. For short distances such as this, the rapid traverse is rarely used. The work is moved over to the tool by hand. The operator takes a short trial cut at the same cross feed of 50 thousandths. The length of stroke and speed remain the same as before. The machine is stopped and the work measured. Notice that the operator, after looking at the drawing, measures the piece to make sure it is coming to size. The competent operator always moves the work clear of the tool before changing the setting of the piece in the vise. Chips should always be brushed away from the machine, but never when the ram is in motion. The second side of the piece has been rough machined, and the operator now measures the width of the piece to determine the metal to be removed from the edges and proceeds with the cut. The first edge has been roughed, the block turned over, and a roughing cut is taken on the second edge. In order to save time, when cutting the ends of the block, the vise is turned 90 degrees as shown by the index dial on the base of the vise. This also allows setting the piece down in the vise to get a more rigid support against the action of the tool. The operator makes sure the clamping bolts are pulled down hard. The piece of wood at the other end of the vise must be of the same length as the block being machined. This wooden piece balances the pull of the vise jaws on the work. The rough cut on the first end is completed and the work reversed. With completion of the cut on the second end, the block has been roughed all over. This rough machining all over is necessary to provide flat surfaces for taking finishing cuts and to eliminate possible internal strains in the piece. With the vise again parallel to the ram, the piece is placed in the vise for the first finishing cut. The operator makes sure that the work is clamped securely in the vise and is solid on the parallels. For the finishing cut, it is now necessary to change tools. One ground especially for finishing must be used. The shape is quite different from that of the roughing tool. The finishing tool follows the surface left by the roughing tool, and therefore cannot be used on anything but a true surface. This means that before he uses the finishing tool, the operator must be sure the surface left by the roughing tool is absolutely true. The cutting edge of the tool is set parallel with the surface to be finished. A feeler gauge is commonly used to check the setting of the finishing tool. Depth of the finishing cut is 5 thousandths. Cutting speed, 1/3 of the roughing speed, or 11 strokes per minute. Finishing feeds for cast iron are from 1/8 to 3/8 depending upon the metal. Since this piece is of medium grade, a hand feed of 3/16 is used. This first finished side now becomes the reference surface to which all remaining surfaces are machined. Now, for the first time, thin papers are used as indicators to show that the work is not tilted in the vise, but is firmly seated on the parallels, so that the two surfaces of the block, when finished, will be parallel. These telltale papers are never used on rough surfaces. The finish cut on the second surface is taken. The careful operator always measures his work before taking it out of the machine. When machining the edges, the piece must be squared to the reference surface. For this reason, the reference surface should always be placed against the solid jaw of the vise. it is absolutely necessary that the operator shall check his work to be sure it is the size and shape called for on the drawing. With the vise again set at right angles to the ram, the operator uses the reference side of the piece to square the work in the vise before finishing the end. He will use this same surface as reference when he resets the block for finishing the other end. The second finished end completes the job. Now, if the work has been carefully seated in the vise and kept free of burrs, if the machine has been set for correct feed, speed, and depth of cut, the proper tools selected and correctly set, the reference surface firmly seated on the parallels, the work squared in the vise against the reference surface, then this splendid example of machine shop work will result. A cast iron block machined to the exact specifications given on the blueprint.